So let's now do a complicated one. Okay, so let's do a complicated one for us and figure out, well, how does that work? And so what are we going to do? Let's consider that we have a square piece of wood, length 1 meter, length 1 meter on each side, and the total mass of our piece of wood is 14 kilograms. Okay, now we know the center of mass of this whole thing is going to be right there in the middle of it, assuming this is a uniform piece of wood. And then what I'm going to do, though, is I'm going to cut out 1/4 of this piece of wood. So I'm going to cut out, 50 centimeters, 50 centimeters right there. And then I'm going to cut a circle out of it right here. And my circle that I cut out here is going to have a diameter of 40 centimeters, and I'm going to put the center of it 25 centimeters from each end. Okay, and so I want to know where's the center of mass of this. So I'm now throwing away a big chunk of it. So obviously we expect the center of mass to move to the left, okay, and then there's more cut out of the top than the bottom, so the center of mass should move down a little bit. And so we would expect the center of mass to be over here somewhere, but I want to know where. So how would I calculate that? Okay, so there's an easy way and a hard way. The hard way is what both of them is that the x position of the center of mass is going to be the integral of x dm over the total mass. The y position of the center of mass is integral y dm over the total mass. So all I got to do is do that. Well, you say, oh my gosh, that's hard. But this is not an easy integral to do over that shape. And so how do you do integrals that are hard? Well, you avoid doing them hard. Okay, so you figure out a way of avoiding the integral. And you say, well, wait a minute, xcm here is the integral, x dm, okay, over the total mass. And so I said, well, what have I did here? Well, I cut out some things here. So when I cut it out, that's like having negative mass, right? So I can call this area 1 and that area 2. So this integral x dm is going to be basically the integral x dm of the total thing, okay, minus the integral x dm of 1 minus the integral of x dm of 2. Okay, divided. So in other words, this is going to be equal to the center of mass of the total. Okay, the center of mass of the total. Where's the x position of the center of mass of the total? Okay, and so the x position of the center of mass. So this be mass of the total times the x of the center of mass of the total minus the x center of mass of object 1 times mass of 1, how much I cut out, minus x center of mass 2 times however much I cut out of 2. Total mass is now going to be that, because basically I have negative mass because I took it out. So where's the, so if I put my origin in the middle, that means the x position, the center of mass of the whole thing is 0. So what about object 1? Well, where's the x position of that? Well, that's going to be over 25 centimeters. What about object 2? Well, that's also over 25 centimeters. So that means that this is 25 centimeters, that's 25 centimeters. So all I need to do is now find the mass of object of the piece 1 and mass of piece 2. Okay, so how do I find the mass of this 1/4 that I cut out? Well, duh, it's 1/4. So for that object right there, object 1 here, that's going to be 1/4 of the total mass. So that's going to be equal to 3.5 kilograms. Now, what about this part that I cut out? That's a little bit harder. Okay, so the entire thing, mass M, okay, was 14 kilograms spread out over 1 square meter, because this is 1 meter, that's 1 meter. So I define something called density, area density. The area density is the mass per area. So in that case, it's going to be 14 kilograms divided by 1 square meter. So this is 14 kilograms per square meter. So if I want to find the mass of my little piece right here, the mass 2 is going to be the area density times the area of 2. Well, what's the area of 2? The area of 2 is going to be pi r2 squared. Okay. So mass 2 is going to be the 14 kilograms per square meter times pi times r, which is 0.2 meters squared. And so mass 2 comes out to be 1.76 kilograms. So now I'm ready to do the entire thing here. Okay, I cut out this, cut out that. So where's the x position of the center of mass? Well, that's going to be, I said 0 for the whole thing, plus 3.5 kilograms at 25 centimeters, except this is negative because it's negative mass, because I took the mass out, okay, minus the 1.76 kilograms times 25 centimeters divided by the 14 kilograms minus 3.5 kilograms minus 1.76 kilograms. So that means the x position of the center of mass overall total is minus 0.15 meters. So in other words, it's shifted to the left 15 centimeters. Okay. Well, this is a two-dimensional object. So what about the y center of mass? Again, if I put my origin right here, then that's going to be the mass of the total thing times the y center of mass, the total, minus the M1 y center of mass of 1 minus M2 y center of mass of the other, okay, and so divided by M minus M1 minus M2. So what's that going to be? Well, that's going to be equal to, once again, that's 0 if I put my origin in the middle, so this will be minus the 3.5 kilograms times the y here, which is 25 centimeters, okay, minus the other one, which is 1.76 kilograms times, well, its y center of mass is a negative 25 centimeters, okay, 14 kilograms minus 3.5 kilograms minus 1.76 kilograms, so the y center of mass actually comes out to be a little bit different here. It's going to be coming out to be minus 0.0498 meters. So in other words, that's about 5 centimeters. So 1 meter by 1 meter, the center mass, the whole thing is right here. If I cut out this and I cut out that, then the center of mass moves over 15 centimeters and down 5 centimeters. So the new center of mass is going to be right there. Okay, so that's how you would do it for a complicated system of this sort.